Okay, hi folks, here we go again. It's another National 5 Physics paper, multiple choice 2015. Questions 1 to 20. If you want to have a go at the paper first, then come back once you've got your answers and we will go through the whole thing. As per usual, first thing you see is the data sheet. Don't forget to refer to that if you've got any questions that require additional information. So we're going to jump straight in. This is question 1. Two circuits are set up as shown, and both circuits are used to determine the resistance of a resistor R. Which row in the table identifies meters X, Y and Z? Well, meter X is measuring the resistance of the resistor directly, and if it's measuring it directly, then meter X must be an ohmmeter. Measuring in ohms, it's an ohmmeter. In the second circuit, we've got 2 meters, one across the resistor, it must be the voltmeter, and one in series with the resistor measuring the current through the resistor, so that one's an ammeter. So there's our 3 meters, an ohmmeter, a voltmeter and an ammeter, X, Y and Z. Let's see which row in the table corresponds to that. Ohmmeter, voltmeter, ammeter, it's A, and that's question 1. Electricity. On we go, question 2, still electricity. It's a triple statement question. Which of the following statements is or are correct? The voltage of a battery is the number of joules of energy given to each coulomb of charge. Yes, it is. That's the definition of voltage or potential difference. Statement 2, a battery only has a voltage when it's connected in a circuit. Nope, that's not right. A battery will have a voltage across it, whether it's supplying a current or not, as long as it's got energy in it. And statement 3, electrons are free to move within an insulator. No, they're not. Electrons are free to move within a conductor. So statement 1 only, that's 2A. Question 3 is a mixed series and parallel circuit here, and we've defined the total resistance between X and Y. So the suggestion is you always do the parallel bit first. So how do we add 4 and 4 in parallel? There is a relationship for you to do that. 1 over the total resistance equals 1 over R1 plus 1 over R2. That's 1 over 4 plus 1 over 4. Quarter plus a quarter is a half. And then that's 1 over RT. So flip the whole lot upside down. RT over 1 equals 2 over 1. So the total resistance of the two resistors in parallel is 2 ohms. And then we have to add that to the 4 ohm that it's in series with. There's your relationship for adding series resistors. That's 4 ohms plus the 2 that we've just worked out. Gives us a total resistance of 6 ohms. Now, that's answer C. And probably very few folk would do it that way. There's a wee trick you can use here for the parallel bit. If the two resistors are the same, then the total is half of one of them. So the parallel bit's got a total of 2 ohms. 2 plus 4 is your 6. That's question 3. Question 4, this is power. The rating plate on an electrical appliance is shown. We've got some useful numbers here. We've got 230 volts, 920 watts. We don't need the frequency of the supply, but we have to work out the resistance of the appliance. So let's write down what we've got. We've got P, we've got V, and we need to calculate R. The power equation we're going to use is P is V squared over R. Rearrange it and sub in for the 230, don't forget to square it, divided by the power, 920. And if you do that on your calculator, you'll get an answer of 57.5 ohms. That corresponds to answer E. Okay then, moving on to question 5, and question 5 is properties of matter and the gas laws. A syringe containing air is sealed at one end as shown, and the piston is pushed in slowly, and there's no change in temperature of the air inside the syringe. So the volume is going to go down, the pressure is going to go up. Which of the following statements describes and explains the change in the pressure of the air in the syringe? Well, here's a relationship for pressure and volume. P1 V1 equals P2 V2. So the pressure times the volume is a constant. As the volume goes down, the pressure goes up. So the particles will have less room to move around if the volume decreases, and so they will hit the walls more often, and the effect of that then is that there's a greater average force on a smaller surface area. There's our other relationship, P equals F over A. So if the average force is greater and the surface area is smaller, then the pressure is going to go up. Let's have a look at these statements then. Statement A says the pressure increases because the particles have more kinetic energy. No, they don't, because they're not moving any faster. We haven't heated them up. Statement 2, the pressure increases because the air particles hit the side of the syringe more frequently. Yes, they do. That's correct. Let's just check the other ones. The pressure increases because the air particles hit the sides less frequently. Nope. And D says the pressure decreases. No, the pressure doesn't decrease when you push the syringe in. Pressure increases, so that's wrong. And E must be wrong as well. So D and E both say that the pressure decreases, so they're both incorrect. That means we're only left with statement B there. B is correct. That's 5B. Question 6 is still the gas laws. And we're told that the pressure of a fixed mass of a gas is 150 kilopascals at a temperature of 27 degrees Celsius. Now, as soon as you see degrees Celsius in a gas laws question, remember your temperatures must be in Kelvin. So add 273 to convert your Celsius temperatures into Kelvin. And now this question is about pressure and temperature. So we're looking for the gas law relationship P1 over T1 equals P2 over T2. Let's fill in what we know. P1 is 150 kilopascals. The first temperature, T1, is 27 plus 273 is 300 Kelvin. We're looking for P2, and T2 is 47 degrees Celsius. And add 273 to that, gives us 320 Kelvin. So let's write our relationship down. P1 over T1 equals P2 over T2. Rearrange for P2, so P2 equals P1 T2 over T1, and substitute in all the values that we know. So P1 was 150, T2 was 320, and all that is over T1, which was 300. And if you do that on your calculator, you will get 160. And because my first pressure was in kilopascals, then my answer is in kilopascals as well. So I didn't need to substitute in the times 10 to the 3. As long as I remember that if my pressure's in kilopascals, then my answer will also be in kilopascals. 160 kilopascals, and that corresponds to answer 6D. Question 7. The diagram represents a water wave. It's 18 millimeters long. So let's count how many full wavelengths we have in there. There's 1, there's 2, there's 3. So it's 3 full waves, 3 full wavelengths in 18 millimeters. So one wavelength is 6 millimeters. Pretty straightforward. 7D. Question 8, triple statement question. A student makes the following statements about different types of electromagnetic waves. Light waves are transverse waves. Yes, they are. Radio waves travel at 340 meters per second. No, they don't. Sound waves do. Radio waves are not sound waves. And then ultraviolet waves have a longer wavelength than infrared. I'd be tempted to sketch a very quick electromagnetic spectrum here. It's always pretty useful to remember the order of the different sections in the EM spectrum. I usually start with visible in the middle, and then you've got ultraviolet above the violet, infrared below the red, and then X-rays and gamma rays go above the ultraviolet, microwaves and radio and TV waves below the infrared. So there's our EM spectrum. And bear in mind that the short wave high frequency end of the spectrum is the gamma wave end, and the long wave low frequency end is the radio wave end. So statement 3, ultraviolet waves have a longer wavelength than infrared, is incorrect. That means it's only statement 1 that is correct. So it's 8A. Question 9. Alpha radiation ionizes an atom. Which statement describes what happens to the atom? Well, ionization is when atoms gain or lose electrons. All about electrons. So if an atom loses an electron, then that atom will become positively charged. That's 9C. Question 10. A sample of tissue is irradiated using a radioactive source, and a student makes the following statements. The equivalent dose received by the tissue is reduced by shielding the tissue with a lead screen. Well, yes, your equivalent dose would be reduced by shielding the tissue with a lead screen, so that's correct. The equivalent dose received by the tissue is increased as the distance from the source to the tissue is increased. No, the further away you go from the source, then the dose you receive would be decreased, so that's not correct. And the last one, the equivalent dose received by the tissue is increased by increasing the time of exposure to the tissue to the radiation. Yes, the longer you're exposed, then the increased dose you would receive, so that one is correct as well. So 1 and 3 are correct. That 10E, that's pretty tricky to read that one. Question 11. A sample of tissue receives an absorbed dose of 16 micrograys from alpha particles, and the radiation weighting factor for alpha particles is 20. So the equivalent dose received by the sample is, well, we need our relationship here, H equals D times the radiation weighting factor. That's DWR. The dose was 16 micrograys, and the radiation weighting for the alpha particles is 20. Now, I'm not putting in the times 10 to the minus 6 for micrograys here, because whatever my answer is for my equivalent dose, it will be in microsieverts. So 16 times 20, 320, and that's in microsieverts. And that then corresponds to answer E, 11E. Moving on, question 12. For a particular radioactive source, 240 atoms decay in 1 minute. Activity is the number of decays per second. So 240 divided by 60. That's equal to 4 becquerels. Corresponds to answer A, 12A. Nice and straightforward. Moving on, question 13. The letters X, Y and Z represent missing words from the following passage. During a nuclear X reaction, 2 nuclei of smaller mass number combine to produce a nucleus of larger mass number. Well, small nuclei fuse together to produce a larger nucleus, so that's fusion. So X is C or E or A. Let's keep reading. During a nuclear Y reaction, a nucleus of larger mass splits into 2 nuclei of smaller mass number. That's fission. So Y is fission. So that could be A or C or E. Right, we're no further forward, so keep going. Both of these reactions are important because these processes can release Z, and Z must be energy. And energy is B or E. So which row's got all 3? It's row E, that's 13E. 14. Which of the following quantities is fully described by its magnitude? Magnitude means size, so that means which of the following is a scalar? Well, if only one of them is a scalar, that means that the other 4 are vectors. And the 4 vector quantities you need to be familiar with at National 5 Physics are displacement, velocity, acceleration, and force. And we can include weight in there as well, because weight's a force. Those are the vectors. And let's have a look at the answers. Well, that's a vector, velocity is a vector, acceleration is a vector. Energy is the only quantity that's there that is a scalar quantity. Question 15. The table shows the velocities of 3 objects, X, Y and Z, over a period of 3 seconds, and each object's moving in a straight line. Which of the following statements is or are correct? Well, let's have a little look at the table first. The velocity of X is increasing at a constant rate. It's going 2468. The velocity of Y is also going up at a constant rate, but the velocity of Z is not increasing at a constant rate. It is increasing, but not at a constant rate. So which of the following statements is or are correct? X moves with a constant velocity? No, it doesn't. It's accelerating. Y moves with a constant acceleration? Yes, it does. And Z moves with a constant acceleration? No, it doesn't. So it's 2 only. And 2 only corresponds to answer B, 15B. Question 16. A car of mass 1200 kilograms is travelling along a straight level road at constant speed of 20 metres per second. The driving force is 2,500 newtons and the frictional force on the car is 2,500 newtons. So those forces are balanced. So the work that we have to do against friction can be found from this relationship. Work done is equal to the force that we use times the distance that we move. And that force against friction is 2,500 newtons. So we have to use that force to keep moving at a steady speed over a distance of 50 metres. So 2,500 times 50 is 125,000 joules. And that corresponds to answer C. That's 16C. You might be tempted in this question to say that the unbalanced force is 0, so you're not doing any work, but you're doing the work done against the friction. So remember that work done is the force that you use times the distance that you move, and that will give you the work that you do in joules. Question 17. A person sits on a chair which rests on the earth, and the person exerts a downward force on the chair. This is Newton's third law here. The person exerts a downwards force on the chair. So the reaction force to that is the opposite of that. So if we've got the person exerting a force downwards on the chair, then the reaction to that is the chair exerting a force upwards on the person. And that is answer A. First one, the force of the chair on the person has got nothing to do with the earth, and it can only be answer A. Question 18. A package falls vertically from a helicopter. After some time, the package reaches a terminal velocity, and a group of students make the following statements about the package when it reaches a terminal velocity. Statement 1. The weight of the package is less than the air resistance acting on the package. Well, no, at terminal velocity, it's travelling at a steady speed and the forces are balanced. The weight is equal to the air resistance, so that's wrong. Statement 2 is correct because it says the forces are balanced, and 3 is incorrect because the package is not accelerating. It is falling at a steady speed. So only statement 2 is correct. That means 18B. Question 19. The distance from the Sun to Proxima Centauri is 4.3 light years. This distance is equivalent to, well, we need to work out the distance that 1 light year is, which we do by distance equals speed times time, the speed of light, times the time, the number of seconds in a year, and then we multiply that by 4.3. So the number of seconds in a year, 365 days, times 24 hours in a day, times 60 minutes in an hour, times 60 seconds. That'll give us the number of seconds in 1 year. And then don't forget that we want to multiply that by 4.3 because we want 4.3 light years. A light year is a distance. It's the speed of light times the time in 1 year. And if we want 4.3 light years, then if you do it on your calculator, you'll get 4.1 times 10 to the 16. That's 19E. Okay, last one, question 20. And this is about the line emission spectrum from different elements or line spectra. And we have a line spectrum from a star in the first row there. And we have to identify what elements are present in that line spectrum. So let's look at them individually. Calcium, that line is not present in the line spectrum from the star. So there can't be any calcium in the star. And that line in the sodium spectrum is not present in the line spectrum from the star, so there's no sodium in the line spectrum of the star. But all of these lines in the helium and hydrogen spectrums, they match up with the lines in the line spectrum from the star, and so we can deduce from that that the star only contains the elements helium and hydrogen. So that's question 20, D. There you go, that's the 2015 multiple choice paper, questions 1 to 20. Hopefully I've got them all right, and I hope that helps. Catch you in the next one.